Welcome to the solutions to the momentum problem set, problems number 1 and 2. Let's start by reading and highlighting key information here in number 1. We have a 0.10 kilogram ball, mass, is thrown straight up into the air with an initial speed of 15 meters per second, VO. Find the momentum, little p, of the ball at its maximum height and halfway to its maximum height. A is really easy to answer. As you know, for an object thrown straight up into the air, the velocity at the maximum height is 0. Since momentum is mass times velocity, if the velocity is 0, then the momentum would be 0. B is a little bit more challenging. We need to find the momentum of the ball halfway to its maximum height. The first thing we need to do here is to find the maximum height. We know that the maximum height, again, the velocity is 0. We have initial speed of 15 meters per second, and we know that acceleration due to gravity also acts on the object. We are looking for a distance, so it makes sense that we would use v squared equals vo squared plus 2ax to find the height total attained, and then we can divide that in half to find the halfway height that we need to do the calculation. So we have 0 squared equals 15 squared plus 2 times negative 9.8 times x. Nice reminder here that we have our 15, which is directed upward. Our acceleration due to gravity is directed downward. Therefore, we have sign direction conflict and need to take care of that with sign. Solve for x, and we should get approximately 11.5 meters. And then half of x would be 11.5 divided by 2, which would be 5.75 meters. Okay. Now here we have choices. We could use conservation of conservation of energy to find the velocity at the halfway height, which is what we need, or we could use the kinematics equation again to find it. We'll just go ahead and use kinematics. V squared equals VO squared plus 2ax. And what we're looking for is the V value here at the halfway spot. We still have an initial velocity of 15 plus 2 times negative 9.8 times, and we have the distance is 5.75. And solving for V, remembering to take the square root, we get an answer of 10.6 meters per second. And we've taken that out an extra digit so we don't end up sig figuring ourselves there. Now we can go ahead and solve for the momentum at the halfway height. We have P equals mv. The mass was given as 0.10. The speed we found at 10.6. So the momentum, 1.1, it looks like 2 digits, 1.1 kilogram meters per second. Okay, and there's our final answer there. Okay, all right, on to number 2. And we have the front 1.20 meters, that's x, of 1.4 times 10 to the 3 kilogram car, M, is assigned as a crumple zone that collapses to absorb the shock of a collision. If a car traveling 25 meters per second, VO, stops, V equals 0, uniformly in the 1.20 meters, how long does the collision last? Looking for T. What is the magnitude of the average force on the car? F. And what is the acceleration of the car? And they want us to also express the acceleration as a multiple of the acceleration due to gravity. Okay, really neat car safety question here. As soon as you see a question like this, the first thing that should pop into your head is the impulse momentum theorem. That said, for A, it looks like what we need here is not the impulse momentum theorem, but we're just going to use kinematics to solve here. I'm going to teach you a little shortcut on this. We don't know the acceleration. We're asked to find it in C. Doesn't mean we have to do it in this order. But what would take to happen here in 2 steps, we could actually just find the time in 1 step, and here's how we could do it. We're going to do v equals x over t, but we're going to keep in mind that when we write that, what we mean is average velocity. And the average velocity here of 25 and 0, the average of 25 and 0 is 12.5, equals 1.20 over t, so our time is 0.096 seconds. Okay? B, what is the average force on the car? Here's where we're going to apply the impulse momentum theorem. Okay? F, our answer, 0.096. Mass was 1.40 times 10 to the third kilograms. And our change in velocity, final minus initial. Final is 0 minus 25 is our change in velocity. And we solve for F, and we get a negative 3.65. Need 3 digits there. 3.65 times 10 to the 5th newtons. Okay? All right, nice application of impulse momentum theorem. And we finish up with C. What is the acceleration of the car? All we have to do here is a quick little F equals ma. Negative 3.65 times 10 to the 5th equals 1.40 times 10 to the 3rd times a. And that was a negative value on the force, so we should get a negative acceleration. And it looks like the acceleration is approximately negative 260 meters per second squared. They also asked us to express that in terms of as a multiple of the acceleration due to gravity. To do that, all we would do is take our answer and divide by the acceleration due to gravity. And what we get here is 26.5 Gs. So what that means to what that says to us, and the reason they're having you do that is to gain appreciation for the stress on the human body in this case, is that during that collision, the body will experience a force that is 26.5 times the weight of the body itself. And it really is amazing that we can, as a human being, to survive that kind of thing. And obviously you see the importance of these safety features that we build into vehicles. Perspective here, that 25 meters per second is just less than 60 miles an hour. Remember that 60 miles an hour is 27 meters per second. So we're definitely looking at a highway speed here that's in the ballpark of 55 miles an hour, probably just between 55 and 60. All right, more practice to come on these types of questions, as in class tomorrow we'll be tackling number 3.